All right, so here we're going to solve radical equations. So if you haven't yet watched all the other videos before this, the simplifying radicals, the adding, subtracting radicals, multiplying radicals, all those, please go make sure to watch them. It's helpful. But this is just kind of like regular equations at this point. So without further ado, let's go ahead. Let's get into some of these. So all we have to do really in solving these equations is undo the radical, right? Undo the square root. And if you don't already know, it's important you do. The opposite of a square root is squaring something, right? If you square a square root, then those things will essentially cancel out, leaving you with whatever was inside that square root. So here I've got the square root of x equal to 5. My goal is to get x by itself. To get x by itself, I simply just need to remove the square root. So to get rid of the square root, I would square it. Now, whatever I do to the left side, I have to do to the right side. Otherwise, the equation will become imbalanced. So squaring the square root simply is going to have all that stuff disappear and leave me with x. And 5 squared would simplify to 25. So there's your answer, x equals 25. And it's always helpful if you go and plug it back in and see if it fits. Right, if x is 25, then the problem was the square root of 25 equals 5. And, well, that's true, right? So we know that now. X is 25, confirmed. Okay. So we'll get evolved into a little bit more level complication, but here's a simple trick. You can't really get inside a radical until the radical's gone. So whatever is inside the radical cannot be touched until you've squared it and made that square root disappear. So here, when you have the square root of 2x and you're trying to get the x by itself, your first move is not to divide by 2. You cannot divide by 2 because that 2 is still inside the square root. You can't go in, you can't do anything with that 2x until that radical has been lifted. Okay, so our first priority is to square both sides so that square root will disappear. Now 10 squared leaves 100 on the left, and then squaring that, we'll just get rid of the square root, so we have 2x on the right. Now the square root's gone, now we can divide by 2. So when we divide by 2, get that x by itself. 100 divided by 2 is 50, so x equals 50. And it's helpful to see if that fits if I plug it back in, right? 10 equals the square root of 2 times 50. Well, 2 times 50 is 100, right? And we know the square root of 100 is indeed 10. So it's just sometimes helpful to double check to confirm that our answer is right. All right, now notice in this one the difference here. The 4 is not inside the radical, so it's free to be dealt with. So we are gonna apologize for that. We are going to move that 4 first. So general rule of thumb, now that we've seen all the things, is focus your attention on everything that's outside your radical and move that first. Once all that's gone, then deal with the radical itself. Once the radical's gone, then you can deal with everything that was inside of that radical. So here, starting with what's outside the radical, that's this 4. So we're going to deal with that first. I'm going to add 4 to both sides, and that leaves me the square root of x equal to 9. So now I'll square my square root, right? And I'll square my 9. I'll have x equal to 81. So x equals 81. Let's double check to see if that fits, right? Let's plug that in. Square root of 81 equals, square root of 81 minus 4 equals 5. Well, square root of 81 would be 9, and 9 minus 4 equals 5. That's true. Remember, outside the radical, then the radical, then inside the radical. So here on this side, there's nothing outside my radical, which is good. But that 3, notice the 3 is inside. So I can't do anything with the 3 until the radical's gone. So the first thing I'm going to need to do is get rid of the radical so that I can have just x plus 3 equal to 7 squared, which is 49. So now normal equation, subtract 3 on both sides, we'll have x equal to 46. And again, that's helpful to see if that fits if I try to plug it back in. Square root 46 plus 3 equals 7. So that's 46 plus 3 is 9. 49. Square root of 49 equals 7. Again, that's getting kind of finicky, but it works, right? I'll have to be careful on how I touch the screen again. All right, so here's a very intense looking problem, but it still follows the same idea. Talk about outside the radical, then do the radical, then do inside the radical. Okay, so now we're not focused on the 10. We're only focused on the side that has our variable. We're only focused on this side. So on that side, outside the radical is my 6. So I'm going to take care of this first. Subtract 6 on both sides. That'll leave me my square root, 5x plus 1, equal to 10 minus 6, which is 4. Now the 5x plus 1 is all inside the radical. So there's nothing left outside the radical. I can't go inside the radical until the radical is gone. So we'll square both sides. That'll remove my radical, leaving me with 5x plus 1, just simply without the radical now. 4 squared is 16. So now it's just a normal equation, right? Subtract 1. 5x equals 15. Divide by 5. We get x equal to 3. Now, maybe a bit of a handful here, but let's plug that 3 in, see if it fits, right? So square root 5 times 3 plus 1 plus 6 equal to 10. So that's 15 plus 1. 15 plus 1 is 16. And square root of 16 is 4. 4 plus 6 equals 10. So it works. Right? It's kind of worth the effort sometimes just to check. And I think there's one more I want to do. Well, okay, it wasn't one more, but oops. Here. So ignore the fact that it says method 1. Outside the radical is my 4. Now 4 is being multiplied to the radical. So to get rid of the 4, divide it, right? Divide that 4 off. And we'll have the square root of x equal to, what's 32 divided by 4? 8. There you go. And then we'll square it. We get x equal to 64. So that should be right. Let's see if I plug it in and if it fits. 4 times the square root of 64 equals 32. Well, square root of 64 is 8. 4 times 8 is 32. That checks out. So it works. All right. Same idea. So remember, outside the radical. 2 is outside the radical, so I need to get rid of that 2. So since the radical is being divided by 2, the opposite, and what I'll do on both sides, is multiply by 2. That way the 2 will go away, leaving the equation to be 12 equals the square root of x. And so now, just square to remove that square root, get 144 equals x. And worth my time, let's check to see if that fits. 6 equals square root of 144 over 2. That's 144 is 12. 12 over 2 is 6, right? 12 divided by 2 is 6. That checks out. Confirmation that it works. All right, here we're kind of doing both those things at the same time. We're multiplying by 2 and we're dividing by 5. I always like to take care of that dividing part first. So just like in the last problem, to get rid of something that's being divided, multiply it to both sides. So that way we get 2 square root of x equal to 4 times 5, which is 20. And now, to get rid of something that's being multiplied, now we'll divide it, right? That'll leave me the square root of x equal to 10. So I square it, and I should have x equal to 100. So, just to see if that fits, 2 times the square root of 100 divided by 5 equals 4. Let's see. 2 square root of 100 is 10. Divided by 5 equals 4. Well, 2 times 10 is 20, right? And 20 divided by 5 equals 4. That's true. So it all works. Okay. Again, this was just me checking my work here. They did a very different method than I did, but that's fine. All right. So here's what I want to talk about. And it's actually kind of simple, right? Think of it like this. If I said that, let's just erase that. All right. If I said I had the square root of 8 here, right, equal to the square root of something, what do you think that something is? Well, that something is 8, right? Square root of 8 would equal square root of 8. If I said square root of x plus 1 equaled the square root of x plus something, right, what do you think that something would be? That something would have to be 1, right? Because x plus 1 would be the same as x plus 1. So what I'm getting at is that 2x minus 1 has to be the same as x plus 7. So just make that equation. 2x minus 1 is equal to x plus 7. Another way of thinking about the problem is, well, if you don't want the square roots there, why don't you just square both sides? Squaring both sides gets rid of the square roots and leaves you with the same equation anyway. But I like thinking of it the way I kind of explained it the first time. So solve this, subtract x on both sides. That leaves me 2x minus x, which is 1x. And then add 1, and we have x equal to 8. So you can see if that fits, right? Let me erase this. See if it fits over here. So square root 2 times 8 minus 1 equals square root 8 plus 7. So this would be 16 minus 1, and this would be 8 plus 7, which is 15. Now 16 minus 1 is 15, right? So square root of 15 equals square root of 15. That's obviously true. So good way to check. All right, I think I'm going to end it here. I don't think there's any more slides after this. So yeah, that's it. I'll leave you guys with that. Go ahead and rewatch it if you want to see something that reworked, or yeah, just come to tutoring if you need anything else. All right, I'll see you later.